Hey there, this is a supplemental video to CPSC 330 Lecture 5 on Bayesian hyperparameter optimization, which is what we didn't have time to cover in lecture today. And I know some people say Bayesian and some people say Bayesian, and I might even say a mix of both, but anyways. Okay, so both Grid Search CV and Randomized Search CV do each trial independently, meaning if they try some hyperparameters and they're really good or really bad, they don't use that to inform what else to try after that. And there were some of you pointing this out in the chat, like, hey, why don't we do this? So yes, you can do this. And there's a package called Scikit Optimize. It is not scikit-learn. I believe it's made by different people. And you have to install it separately, but we put it in the environment, so you should all have it installed already if you installed the whole course environment. And it uses a technique called model-based optimization, and specifically Bayesian optimization. And I'm not really going to go into it, but it uses machine learning on this higher level hyperparameter optimization problem. So it tries to predict, if you've done 10 different sets of hyperparameters, it tries to predict what's going to be good or bad, and use that to try to pick good decisions for what to try next. So yeah, it's like machine learning on machine learning. It's like this very many layers of meta. And so Scikit Optimize is called SKOpt when you import it, and the thing is called Bayes Search CV. And as you can see with the CV, like they intentionally modeled it after the scikit-learn interface. Everything, the syntax is all exactly the same, so you don't really need to learn new syntax. But I just want to tell you, like, when would this be useful and when would it not? Pros and cons, that kind of thing. So, okay, so this syntax part is slightly different. The way you specify the parameters, like, you can read in the documentation. But I think by default, if you put in two numbers, it interprets this as a range, like anything between 0 and 300. Somewhere we need to tell it that those are integers, or maybe, I don't remember. You can check the documentation. Here I put in a list of things, but there's a slightly different way to specify the parameter space than the scikit-learn ones. The rest is the same: an iter, number of folds, random state, how much output, whether to refit the thing on the entire training set afterwards. So that's all the same. And so this is all the same. You call fit. I just put the percent time for it to print out how long it took. The Grid Search CV and Random Search CV automatically print out how long it took, but maybe that's because of the verbose, and maybe if I set verbose to 1 or 2 here, it would do that. Anyways, percent time, you can just time any Jupyter cell that way. So that's a handy little thing. And yeah, it's running, and okay, we can just read ahead. It looks like it took longer. The reason why it's taking longer for the same number of iterations, or actually 10 iterations instead of 12, is that it's not doing the parallel thing. And I'll talk about that in a second, but it's not using my 8 cores the way the other ones were. There's also some extra computation in that at each iteration, like just picking a random thing or a thing on a grid is instantaneous, but it has to do some thinking. It has to build that meta machine learning model. That also takes a bit of time here. That's negligible. But if you do like 100 iterations or 1,000, as that meta data set gets bigger, that might take some time too. So, okay, it ran. It did its thing, 55 seconds. Yeah, okay. So it got some params. It got some score. And we can again just call Bayes_opt.score is shorthand for Bayes_opt. Give me the best thing you found. .score. So here it seems like it actually did a bit worse. Yeah, okay, it did worse. I mean, in general, I try not to shield you too much from. I try to just pick something and show it to you instead of picking out the particular case where the thing I'm showing off works. Or at least I try and find a nice balance between being real but also showing you cases where things shine. Anyways, yeah, so in this case it wasn't so great, and possibly even worse in a real way, not just a random noise way than the other two. But okay, we only did 10 iterations, so it didn't really have that much opportunity to learn from the past trials, and also there's just a lot of random luck here. Like, how good is random search going to do in 12 trials? Well, that's very random. Yeah, so basically, when should you use this, and why or why not? So the advantage is that it could find you better hyperparameters. Yeah, the other thing, it could find you better hyperparameters, and in cases where it takes a long time to try one set of hyperparameters, you might be like, you know what, I want my best minds on this, picking the next hyperparameters. I don't just want to randomly pick it and then wait an hour for it to finish, or 10 hours. I want to really intelligently pick the next thing, and then this Bayes search really pays off. I mean, here it wasn't that slow. You could just do more trials. But yeah, you have to install a separate package. In a very large number of trials, at least back in the day, hopefully they've improved things now, but the actual meta machine learning can get slow. That's a solvable problem. Hopefully they solved it by now. The parallelization is a super interesting aspect of this that I really want to highlight. So grid search and randomized search are embarrassingly parallel, meaning you can just do the 12 things on 12 different nodes and they have nothing to do with each other. Here you cannot do that, because remember, your choice of what hyperparameters to try next depends on what you did so far and how well they did. That's the whole point of it. And so you can't do all 12 at the same time, because by definition you need to wait for the previous one. So it turns out, if you look in the documentation, this Bayes search thing does have an njobs parameter. And so what it does is, if you set njobs equals 4, it'll do 4 all at the same time, wait for the 4 to come back, learn from what it saw there, and then do 4 more. And so that's kind of interesting, because it's like this balance between it'll be faster if you increase njobs, but the end result will be worse because it didn't. It's better if it can do one, learn from that, do one, learn from that. That way it's always learning from the maximal amount of stuff. Whereas if you do 4, those 4, none of them could learn from anything. And so with randomized search and grid search, if you increase njobs, it's just like the exact same thing but faster. Here, if you increase njobs for the same number of iterations, your result will probably not be as good. But if it's faster, you could also do more iterations in that amount of time, and overall it'll be a net win. So you should still probably use all the cores you have. I just say do 8 cores and do 8 times more iterations, and that seems definitely better. Yeah, so anyway, it's hard to say when this is a good idea to do. I have this kind of gut feeling that so some of these methods, like the ones I worked on, tended to work better for continuous hyperparameters like C. We haven't seen a lot of categorical hyperparameters yet, but we will. Like, should I use this option or that option? But yeah, there's kind of a sweet spot in number of hyperparameters, maybe like 10-ish, a number of trials where this can do way better than grid search or random search. But I would generally not say, this is the ordering. It's really problem dependent. I would say most of the time I would pick randomized search over grid search for the reasons I talked about earlier. But whether I would choose randomized search or Bayes search, it kind of depends on the properties of my problem. Again, if it's like super slow and super hard problem, maybe the Bayes thing is worth doing. If I don't really care, or I don't think the hyperparameters matter that much, or I don't feel like installing this extra thing, or whatever, there's plenty of reasons not to use it. Or maybe it doesn't work well for the certain type of hyperparameters I'm using. So I guess that's all I really wanted to say about this. To summarize, it's very easy to use as long as you just install this extra package, because the syntax is pretty much the same. It's doing some super complicated stuff under the hood involving Bayesian statistics, and that's why it's called Bayes Search CV. So it's doing something fancy to decide what to try next based on the results so far. And just again to double confirm, these results, they are given a set of hyperparameters like min df equals 10 and c equals 5, how good is the 5-fold cross-validation error on that? That's one result. And then if that was really good, it might say, oh, well, c equals 5 seems really promising. Let's try c equals 7. That's the kind of learning from the past I'm talking about. But it's a bit more nuanced than that, because it wants to try things kind of similar to things that worked out well, but also wants to explore new places that it hasn't explored before, and it does some clever stuff under the hood. I guess that is all. Maybe it didn't even take 10 full minutes.